Okay, let's go ahead and talk today about factors. We're starting chapter 4. A factor is a whole number that divides into another whole number with a remainder of 0. Any number is always divisible by all of its factors. Okay, so factors of 30 are numbers that you can multiply together to make 30. So for example, 1 and 30. And I'll show you why I'm spacing it out like that in just a second. 2 and 15. I can do 3 times 10 or 5 times 6. Okay, so listing them out like that ended them or gave me my final answer in numerical order, which is what I want. Okay, the factors of 42, 1 and 42, 2 times 21, 3 times 14, right? Because 4 plus 2 is 6, and 6 is divisible by 3. And then it's not divisible by 4, not by 5, and I know it's divisible by 6 because it's divisible by 2 and by 3. So 6 and 7. So those are the factors of 42. So over here in this box, it says, tell whether the first number is a factor of the second. So is 5 a factor of 20? Yes, right? 5 goes into 20. Is 12 a factor of 46? No, 12 does not divide evenly into 46. Is 3 a factor of 22? Nope. Is 9 a factor of 18? Yes. Is 7 a factor of 56? Yes, 7 times 8 is 56. And is 5 a factor of 35? Yes, because 5 times 7 is 35. Okay, so the next part says, writing a composite number as the product of its prime factors shows its prime factorization. You can use a factor tree to find the prime factors. So here's how you do a factor tree. We're going to start with our number, and we're going to figure out, name any pair of numbers that you can multiply together to make 60. So I'm just going to say 3 times 20. And now I'm going to circle my prime numbers. And if y'all remember, prime numbers are numbers that only have, or they have exactly 2 factors, and it's 1 and the number. So what can I multiply together to make 3? 1 times 3, and that's it. So 3 is prime. 20 is not prime, it's composite because it has multiple factors, right? 1 and 20, 2 and 10, 4 and 5. Okay, so now what we're gonna do is we're gonna figure out, okay, we're gonna keep going because 20 isn't prime. So I'm gonna say, well, 20, I can do 4 times 5. And I'm gonna circle 5 because 5 is prime. 4 is not prime. I can do 2 times 2. But 2 is prime, so I'm going to circle both of those. So now I list out the numbers that I multiply together to make 60. So 2 times 2 is 2 squared times 3 times 5. 2 squared is 4. 4 times 3 is 12. 12 times 5 is 60. So this is how, or the prime numbers you can multiply together to make 60. So that's the prime factorization. Let's look at 72. Okay, I can do 8 times 9. Are either one of those prime? No. 8 is 4 times 2. 2 is prime. 4 is 2 times 2. And those are both prime. And then for 9, I can do 3 times 3. And those are both prime, so I circle them. So when I'm writing out the numbers that are prime, I have 2 times 2 times 2, so 2 to the third, times 3 times 3, 3 squared. Okay, so now let's look at 36. Actually, why don't you do this one on your own, and then we'll come back and check it. Okay, so what's going to be cool is that hopefully you'll realize that if you didn't pick the same numbers I did, we're still going to get the exact same prime factorization. Okay, I'm going to pick 4 times 9. 4 is 2 times 2. And 9 is 3 times 3. So when I'm writing my prime factorization, it's 2 squared times 3 squared. Okay, and even if you didn't pick 4 and 9, if you picked 2 and 18 or 6 and 6, you would get the exact same answer for your prime factorization. And then the last thing we have to talk about is greatest common factor. The greatest common factor of two or more numbers is the greatest, right? Let's think about what that means. That means the biggest number that is a factor of all the numbers. And there's two methods of finding greatest common factor. And the first method is making a list. Okay, so factors of 24. 1, 2, 3, 4. It's 4 times 6, 3 times 8, 2 times 12, and 1 times 24, right? I just listed out 1 times 24, 2 times 12, 3 times 8, 4 times 6. Okay, and this should actually be 36, not 26. Okay, so factors of 36 are 1 and 36, 2 and 18, 3 times 12, 4 times 9, and then 6 times 6. And I'm only going to list 6 out one time. Okay, so now if I'm looking for the biggest factor that they have in common, right? Well, they both have a 1, they both have a 2, they both have a 3, they both have a 4, they both have a 6. And they both have 12 as a factor. So the greatest common factor would be 12. That is the biggest one they have in common. This is not my favorite way to find GCF, okay? It's not my favorite way because I feel like there's lots of room for error. It's not super fun to make the list, okay? And it just seems like you could do all the right things, leave off a number, and miss your answer. So my favorite way is using, or one of my favorite ways, is using a factor tree. Okay, so for 24, I'm gonna do 4 times 6. 4 is 2 times 2. 6 is 2 times 3. Okay, these are all of my prime factors. And then for 36, we actually did it up at the top, but it's going to be 6 times 6, 2 times 3, and this 6 is also 2 times 3. And this actually is a good example because look, I get 2 2s and 2 3s. Well, here when I did 4 and 9, 2 2s and 2 3s. Okay, so what we're going to do is we are going to look for factors that they have in common. Okay, so let's see if I was going to pick prime fruit off of both of these trees. What could I pick off 24 and 36? What do they both have? I could pick a 2 from both of them. Okay, what else could I pick from both trees? I could pick another 2. Anything else? Well, 24 has a 2. Does 36 have another 2? No. 24 has a 3. Does 36 have a 3? Absolutely. So the things that they had in common, the prime factors that were in common are 2, 2, and 3. And watch this. 2 times 2 is 4. 4 times 3 is 12, which is exactly what I got up there.